Okay. So, first, these equations on number 1 through 4 are called same base exponentials. We did same base exponentials. We started them in chapter 3 of Math 1, but it's probably been a really long time. Okay, the goal is to get the same base. And if you get the same base, then you can cancel the bases and equal the exponents. So again, the goal is to get the same base. This one already has it. I did a baby one for the first one. And if they are equal, then you can equal the exponents. And this is as easy as this would ever get. This is like the babyest baby one. Minus 3. And then just leave it like a fraction like that. Okay, so again, these are called same base exponentials. The goal is to get the same base, and when you do, you can cancel the bases and equal the exponents. Now this one was easy, but we'll have, as you can tell, more difficult ones coming up in the following days from today. Okay, now go down to number 5. We have an absolute value equation here, and the vertex, yep, is 1, 2, positive 1, positive 2, and the a value is 3, which means that there's a slope of 3 and negative 3, like plus or minus. Okay. Vertically stretched by a factor of 3. Shift right 1. Shift up 2. Okay, so that's it for the packet. So let's look at the front though and check the homework. Night's homework is 8, 9, 11, and 13 in CPA. Okay, now before you get to the notebook, we're going to play a game. It's a fun game called Guess My Number. Okay, you're not writing anything. You're just looking at the screen. I'm thinking of a number that when I triple my number and add 4, I get 10. What number do you triple, then add 4 to get 10?
2.
2, nice. Okay, so what I want to do is come over to this spot and everybody watch how you guys can get the 2 in your mind for this one. But I want to show how we take the answer and we undo the last thing that happened. And then we undo the next thing that happened. So I want you guys to see that it's kind of like a present. You guys know, like, okay, I want you to picture that somebody just handed you a present, like a wrapped present. Okay, so I want you to imagine in your hand, somebody gave you a gift. Inside the gift, somebody wrapped it in tissue paper, and then they put it in a box, and then they wrapped it with wrapping paper, and then they put the bow on. Okay, now how would you undo that gift? Bow off, paper off, box open tissue page. Okay, so that's what I'm saying. Undo the last thing first and then undo as you go in. So basically, these problems are just gifts. Okay, what number am I thinking of if I double my number? Do you already know it? Double my number, add 4, and divide by 2. Okay, let's see. 5. How do I undo dividing by 2? Mm-hmm. And how do I undo adding 4? And then how do I undo doubling? Mm-hmm. Do you guys see I'm unwrapping? Okay. All right. Square my number, add 3. I don't remember. 7. Yep. Undo. Mm-hmm. Good job, Sam. Everybody cool with the square root being the undo of the square? Okay, last one. Uh-huh. Nice. Good job. Okay, here's the good news. That was actually one of our problems. That was 5-1, and you didn't have to do anything. Woo. What? Uh-huh. I know. Okay, so set up this little bit, guys. This chapter starts with inverses. And I'm going to use 2 colors throughout my notes. So if you're the type of person that likes to use colors in your notes, I'm going to use blue and pink. Blue is going to represent the original, and pink will represent the inverse. It's fine. Take your time. We already did a whole problem and the warm-ups. I know. Great. Playing a number game in your head? Not sorry. Okay, so number 2. What is the rule for this table? There's always somebody in the class who's really good at finding the rule. Yes. Beautiful. Okay, so multiply by 2, add 1. Multiply by 2, add 1 is the rule for this table. Unfortunately, I really dislike this pen. Here's my other. I don't want to use this pen. I'm frozen in time now without my other pen. Lost it in the sea of my desk somewhere. Gonna have to use this pen. Is it? It's a good thought, but no. Okay. All right. So the original is f of x equals 2x plus 1. So this represents your multiply by 2, and this represents your add 1. Okay, any questions so far? I would not ask you to find that in your head, by the way. There are always people who can find the rule from the table. I have to do math to do it. It's not a strong suit of mine. Okay, now the inverse. So what I want to do is be very careful here. And I want to talk about like what we were doing on the guess my number thing. So what was the last thing that happened? Add 1. So the first thing I'm going to do is subtract 1. And then undo the most so you're going to work backwards and undo. Undoing multiply by 2 is divide by 2. Okay, now how is this going to look in a table and an equation? First thing I need you to know is that this is the symbol for f inverse of x. This is not a -1 exponent. It looks like one, but it's not. It's the symbol for inverse. So when you say this, you say f inverse of x. Okay, and when you write these, you write the steps, and then you follow the steps, but you have to start with an x because you have to have something to do the steps to. Okay, so you start with an x. Every problem, you're going to start with an x. Then subtract 1, and then divide by 2 on everything. I'm going to say on everything about 57 times this chapter. So just mentally prepare yourself for Mrs. Talbot saying on everything a lot of times. Not everything. I'm going to say on everything, on everything. Okay, now what about the table? The original table, this is the best part of this chapter right here. The original table and the inverse table are just flips. Everyone always gets that right. It makes me so happy. Oui. Okay, and we're going to practice this a bunch of times today. So that was number 1. Number 2. I know. Number 5 is not short. But that's the only one. Okay, now set up number 3. Okay, I have a line y equals 5x plus 22. We're going to find the function value at 4, which means we're going to plug 4 in for x. So 5 times 4 plus 22 equals 42. Okay, now the whole point of that was to kind of establish order of operations so you could see it visually. If I plug 4 in, what would be the first thing I would do to it? Multiply by 5. And then add 22. Okay, kind of, except for you've got to go backwards from the outside. So you have to take the bow off first, right? So we have to undo in this direction. So subtract 22, divide by 5. Okay, now when you're writing the inverse, again, you have to start with an x because you have to have something to do the steps to. And then follow the steps. Subtract 22, divide by 5 on everything. On everything. Okay, now we're going to do the check. And these problems are great because if you actually plug a number in, you can check to make sure your inverse is correct before you walk away from the problem. So what I mean by that is we're going to check F inverse of 42. We're going to take the output from this problem and plug it into the inverse. What do we want to get back? 4. Okay, so F inverse of 42 is 42 minus 22 over 5, which is 20 over 5, which is 4. So that means that our inverse is correct. We go full circle. 4 to 42, and then 42 back to 4. Pure excitement, I know. Okay, on this problem, we're going to write the original function, then we're going to find the inverse steps, then the inverse function. Okay, so start with plain f of x because you're finding the original. You could put y if you want to, and then put y inverse. I don't care, just as long as it's some sort of y equivalent equals. Okay, and always start with x. So if you're writing an equation off of steps, you need to do the steps to something. So you have to start with x. Okay, add 5. Divide by 2 on everything. Cube everything. Multiply by 6 on everything. Okay, now I hate the way this looks. So I'm going to take the 6 and put it in the front as the a value. And that's really just because of looks. I just want that a value constant to be in the front. Okay. Do you guys have any questions about how I got the original function? You sure? You sure? You sure? Yeah. Positivo. Okay. Now, what will be the first thing I'm going to undo? Okay, yes, you answered two questions in one. The first thing I'm going to undo is multiply by 6 by dividing by 6. Yep, then cube root. Okay. F inverse of x equals. Okay, start with an x. And I'm going to move the x a little bit over because I could sort of see what's coming. You'll get better at that as time goes on. Okay, divide by 6. Cube root everything. Multiply by 2 on everything. And you see, if I had my crystal ball out, I could have left room in the front to do the times 2. Subtract 5 from everything. Done. So what I really want you to be getting is undoing the last thing that happened and then the second to last thing and then in that direction. And undo, 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 undo as you go back. Okay. The next one is going to be group productive struggle. All right, so I will get you started, but first we're going to write it down. Oh, hold on. Group productive struggle. I love these notes. I think they're so pretty. Just saying. Okay. So write them down first. Yeah. Okay, this is what I want you to do. Are you ready? Okay. I want you to list the steps of the original in bullet point. List the steps of the inverse in bullet points and write the inverse function. So for example, for A, you're going to put a bullet point, multiply by 3, subtract 6. And then you're going to say add 6, divide by 3, and then write the inverse function. Does that make sense? Yes. Okay, work through all 4 of them. And as we go, I will reveal more of the answers so you can check them. And talk it out. Talk to people. Discussion's good. I also said list the steps. I didn't say do it in your head. There are people who do this in their head all the time. It drives me crazy. Yeah. So Debbie.
On everything. On everything. Okay. Everything.
Okay.
I like to think about it.
On. If,
I know, I like to.
yeah, they're good. Please tell me.
Give me a second, like,
Okay. Okay, so proceed.
Yeah.
Okay, I love this. Okay, so
I do.
you have to do your PEMDAS. What I suggest is if it looks confusing, plug in a 1 in your mind. Okay, so pretend X is what? What would I do? Plus 3. Then Q,
Oh.
then times 2. Remember, parentheses, then exponent, then multiply. PEMDAS.
But if I'm not sure, because sometimes that happens, I'll actually plug a number in to see what I would do. I put up the answer for A, so you can check to make sure you're on the right track.
On anything. Okay. One of them.
You don't want to have it. Send me the copy.
I got the Pathfinder and then. Of your phone. So, software.
You guys have an extra copy?
Yeah.
Just trying to see if there's any. Okay, gonna show the answer for B. Take a look when you're ready. This one.
Yeah.
It's to the back. Yeah.
I have it right.
Mhm. I think so.
I'm done.
Let me see. So the -3 should happen last though.
Yeah.
So the first thing you would do is you add to,
Then it's all ready. Yeah.
Right, yeah. One.
Those both in time, but my name.
masterpiece. We'll be in Sean's group for the team test.
I do that.
Yeah, I know. It's helpful. You can hear my little voice when you're taking your test.
About by two.
Yeah, you did, but differently.
Yeah. 3x over 10 divided by 10 plus 4. 3x over 10 divided by 4.
Minus
What?
minus 1.
I'm not here.
I do that one.
Blue, my son.
With multiple.
For English?
The inverse,
Original.
Right. Explicitly, that's first, right, and then afterwards. So then both sides.
Yep, multiply by 2 is at the end, yeah. Parentheses, then use, then times. Yep. Or. Okay.
Divide by 10.
Take a look at D when you're ready.
It's still C, but it's some C minus, that's already new C. I know what's on
Is there any of these that you want me to talk about? No? I like these problems. Okay, we have one more.
Nope.
It's not notes. It's just a one that we have to look at, the graph and what happens with the graph. So, graph, inverse graph. It's not a big deal. Okay, here's the last problem of the day already. It's not, uh-oh, it's fine. This is not scary, I promise. Definitely not an odd function. Just doesn't have the origin. That's not this lesson at all, though. Okay, so this last problem, what we're going to do is graph the function, shocking. Find the inverse, graph the inverse, and look at their relationship to each other. And then we're done. And I think that reviewed all of Math 2 inverses in one day. Yeah, you did inverses in Math 2. No?
This facility did not teach this.
Well, I don't know. I just pretend that you've never seen it before. I just teach it from scratch. So you just never know because all the Math 2 teachers do something different. So I don't know. Okay, let's do some mental maths. What's -2 cubed? -8. -8 minus 5. -13. What's -1 cubed? -1 minus 5. -6. We're probably not going to graph the 13s. That's okay. 0 cubed is 0 minus 5. 1 cubed is 1 minus 5. 2 cubed is 8 minus 5. Okay. All right, so I'm just going to start with this guy, -1, 2, 6. That's supposed to be -6. You're just going to let me go with that? You're just going to sit by and 1, 2, 3, 4, 5, 6. I made a mistake. I'm trying to blame you. 0, -5, 1, -4, 2, 3. Okay. So, when you graph this, come up here and then make the flat bit at the inflection point. Yeah, that's not too bad. Okay, now I have a question. What is the inverse of this? You did this already. Look at your previous problem. What's the inverse? Mm-hmm. Okay, so what does a cube root look like? Okay, now we could do mental math on a table to figure it out, but what we're gonna do instead is flip the table because in original and its inverse, the table flips. And we're not gonna graph this first one again. 2, -6, -1, -5, 0. Okay, now I'm really bad at drawing cube roots as we've discussed, so I'm gonna go this direction with my notebook. I kind of missed the points, but it's fine. You get the idea. Okay, now after you get your two weird graphs graphed, so you should have two tables, original and inverse table. You should have the inverse function, which normally we would do with steps, but you guys already did it in 5.5b. And you have your two squiggly graphs. What I want you to do is turn your notebook 45 degrees counterclockwise. Turn your notebook 45 degrees counterclockwise. And if you did your graphs correctly, there should be symmetry. Can you see the reflection symmetry? Okay, so if you have anything with the straight edge capabilities, what I want you to do is draw in the line of reflection. Anything, I'm gonna do green, but you can do whatever you want. Okay, now here's my next question. What is the equation of that line of reflection? Y equals X. Okay, and why does it make sense from the tables that they would be a flip along Y equals X? Because we flipped the X and Y in the tables. Since we flipped the X and Y in the tables, they are a flip on the line Y equals X. And you can always check your graphs that way by making sure that they're symmetric on that line. So you can check your equations by plugging in a number, and you can check your graphs by looking for symmetry. Pretty cool. That's it. I'm done.
I like that. We can come down.